the solutions to AP Physics Practice Exam 1. And here we go. So we have our data booklet, formulas, etc. Let's jump in and take a look at this first problem. So we want to determine the frictional force on this box. Let's draw a free body diagram. So we have the normal force on the box due to the platform. We have the weight of the box due to the earth. And the idea here is that we have sort of an acceleration force and then a friction force opposing that. And we want to determine the frictional force on the box. So in this case, horizontally speaking, it's weird because relative to the perspective of the platform, we have to be clear on the fact that these two forces balance relative to the platform. If there were an imbalance, then the box would slide on the platform. So it actually turns out in oh, and it says the upward force exerted by the horizontal flap. Sorry, we should do part A first. So here we're going to say normal minus the weight of the box is the mass times the acceleration because they don't bounce. And that's a downward acceleration. So we'll say normal minus 300 times 10 equals 300 times this negative 1.5 meters per second squared, because that is a downward acceleration. And so what this tells us is that the normal force ends up being 300 times 8.5 meters per second squared, which ends up being 2,400 plus another 150. So we get 2,550 newtons worth of normal force in part A. Now it says the frictional force on the box, that's the part that balances the mass times the acceleration before it slips. So that's going to be 300 times 2, which is 600 newtons worth of frictional force so that the box doesn't slip relative to the platform. Now it says, given that the box does not slip, determine the minimum possible coefficient of friction between the box and the platform. There we're going to use friction is mu times n. So we have 600 is mu times 2550. So I'll actually call this part A. This is part B. Now we're working on part C. And so here we say that 600 divided by 2,550 is mu. And when we actually solve for that, and we end up getting 0.24 for our coefficient. And it's dimensionless. And then it says determine a path for y versus x. So let's write down the equation here. So the y equation, well, y is going to be negative 1.5 t squared. And it starts at a height of 2 meters. And the x equation is 2.5 t squared. Or sorry, is that correct? 2.0 t squared in the horizontal direction. So let's do a little math here. Basically, I know that they're both functions of t squared, so why don't I do a little bit of a substitution here? I'm going to isolate t squared in the equation below. So I get x over 2.0 equals t squared, and now I do a substitution. So y equals negative 1.5 t squared over 2.0 plus 2, and 1.5 over 2 is 0.75, So my final equation for y is negative 0.75x plus 2, since that's the equation for x. And so when I plot this, I'm going to end up getting here y is a function of x. Well, y equals 0 is 2. Now, when x equals 1, y is 1.25. And then when x is 2 seconds, let's see, negative 2 meters, sorry, not 2 seconds, 2 meters, negative 0.75 times 2 is going to be negative 1.5 plus 2, that's 0.5. And then when x is 3, that's going to be negative 9/4 plus 2, that's going to be negative 1/4. So we're talking about a nice little linear plot like that. Use rulers on test, by the way. So that's the first free response question on your first practice exam.